Okay, so this section is working with rectangles. I know you already know a lot of these properties, but we're going to go through some of the ones that you might not know. So this is a parallelogram technically. It's just a special type of parallelogram. We pretty much, when you have the parallelogram, you kind of pull the edges. It's almost like you just push it back. So it keeps all of the properties that it had before, kept the fact that the opposite sides are congruent, they're parallel, same about diagonals bisecting each other. We're going to add in a couple more though. Number one, this one you already know, all four angles are right angles, so if you're given something like here and here, know that the two of them add up to 90 degrees. The second one is diagonals are congruent. That's what makes this one a lot different. We saw before that like this part would be the same as this part. That stays the same. However, it's the same in all four now. And because of that, we get this triangle. Now it's the same on each one, but you get the triangle, okay? And if you split it apart, technically the two sides are congruent to each other now. So if the arms are congruent, the feet are congruent too. So that's where we get our Irene isosceles triangle. So that's going to be a big thing here, okay? Now remind you, this triangle is the same exact triangle as the one above it. These ones are still isosceles triangles. The two here, it's just you'd have different numbers, okay? So moving into some of the practice problems. Okay, so it says find the missing measurements. If this is 15, we just figured out that they're all 15, 15, 15, 15. Okay, if this is 27, this is also 27. Now, I'm looking here, I'm still missing these sides. So what I want you to do is look real quick at this part here, okay? Look at the big triangles. It doesn't matter which big triangle you use as long as you filled in all of the numbers so far. I'm going to just use this one. I tend to use that same one over and over again when I do problems like this. Big thing is that these are right angles, okay? So this is a right angle. This bottom is 27. This length total is 30. And we, at some point when I find this, I might just label it as X. And let's put X there. We know what to do when we see something like this. You use your Pythagorean theorem. So I'm going to have 30 squared equals X squared plus 27 squared. 30 squared is 900 equals X squared plus 729. Subtract 729. Subtract 729. X squared equals 171. Take the square root, take the square root. X equals 13.08. That's my X here. I'm going to put it over here. 13.08, meaning this is also 13.08. And I believe that's everything, so let's go down here. It wants AC. So AC is here to here. That whole length is 30. It wants BD. That whole length is also 30. BE is just half of it, 15. AB, 27. BC, 13.08. Okay. Looking at number 3. The ones with the angles get a little bit weird, but let's look at what we got. We still know we have alternate interior, so that's pretty cool. We also know that these things are right angles all over. If this is 27, we can actually figure out this little side by doing 90 minus 27. When you do 90 minus 27, you get 63. So I'm going to put 63 in that part, 63, 63. And this is where you need to look at your isosceles triangles. So I'm going to look at that triangle specifically for right now. We know these should be the same, are the same because it's a rectangle. So these two have to be the same. So that's also going to be 27. So this is 27, meaning that's also 27. This, if you actually turn it this way, technically this is also an isosceles. So actually I could have used just one dash there, sorry. this is 63, this is also 63. So that's how these kind of work. Okay, now I'm going to look, what else do I have to find? I know this because I've already looked in the problem of what we want. They also want to know this inside angle. So looking at that isosceles triangle, you have 27 here, 27 here, and we want to find this top angle here. So the 3 add up to 180. So I'm going to do 180 minus 27 minus 27, and that gives me 126. That's 126. And I think that's all they asked us for, so let's just look. So it's MJK. So MJK, that whole angle is 90 degrees. MJL, MJL, just that part is 63 degrees. JLK, so JLK, also 63 degrees. KML, KML is 27 degrees, and MNL is 126 degrees. That's it for that problem. I'm going to look at number 4 next. It says find the missing measurements. This one's kind of cool. I like this one. I'm going to put my vertical angle there. I also know that these two are supplementary, so I'm going to do 180 minus 64. When you do 180 minus 64, you get 116. So I'm going to put 116 there, 116 there. Okay, I want to get these outside angles. So I'm just going to look at, for example, I might use this bottom one. I like to use the bottom one there. It doesn't matter which one you use, honestly. You could get them all the same way with whatever one you're getting. So I have 64, and those two are equal to each other. So what am I going to do? I'm going to take 64, and I'm going to subtract it from 180. When I do 180 minus 64, I get... Oh, did I do the other one? It doesn't matter. I get 116 either way. And then I divide it by 2 because each is equal to each other. So I divide this by 2 and I get 58. So this is 58. This is 58. So I'm going to use that. So that's 58. That's 58. I know this triangle is the same. I can figure out these. You can do the same thing, 180 minus this, divide by 2. I just went, okay, these two add up to 90. Remember, there are going to be a lot of different ways that you can do these. It doesn't really matter which one you do as long as you get the same answer. So if you found one that you thought was quicker or you just like that better, do that way, okay? Okay, so I think that's it. So let's look in our actual, what they want. We get XWY. XWY is 58 degrees, YXZ 32 degrees, WVZ is 116, XWZ is the whole 90, XZY is 58. Okay, so we're going to start looking at the ones that incorporate algebra. We know opposite sides are equal, so that's all I'm going to do. Because the two sides are congruent, I'm setting them equal, and I'm solving. That's supposed to be a 9. Sorry about that. Let's subtract 3x, subtract 3x. I get 5 equals 4x minus 39. Add 39. Add 39. Get 44 equals 4x. Divide by 4, divide by 4. I get 11 equals x. That is not what they want. However, we need it. They want to find EF. So EF is this length. Mind you, it doesn't actually matter which one you plug it into. I'm just going to plug it into the 7x. So it's 7 times 11 minus 39, which is equal to 77 minus 39, which leaves me with 38. Okay. Next one, number 8. Sorry, not 9. Okay. JM is x plus 17. JM, x plus 17. MK, 5x minus 23. What do we know about all 4 of these in a rectangle? They're congruent, therefore we're going to set those equal. X plus 17 equals 5x minus 23. Move my x over. We're just doing a little bit of math gymnastics here. Plus 23 gives me 40 equals 4x. Divide by 4. I get x equals 10. Yet again, not done. They want JL. JL is this whole length, so what I'm going to do is I'm going to get this, and then I'm going to multiply it by 2. So it's 2 times x plus 17, which is 2 times 10 plus 17, which is 2 times 27, which equals 54. Okay. Looking at number 10, it says find the measure of angle BCE. BCE, so it's this one that they actually want. What do I know about these two? They're alternate interior angles. They're equal to each other. Therefore, I'm just setting them equal. Okay. You get 5 equals 4x minus 3 plus 3 plus 3. You get 8 equals 4x. Ooh, we are getting sloppy with the handwriting. That's how you know it's summer. Okay, x equals 2, it's not my answer. However, I need to find here. So let's say you found this angle here. All you have to do is 90 minus it. So let's do that. So let's plug in the 2 here. So it's 11 times 2 minus 3, which is 22 minus 3, which is equal to 19. Okay, so if this is 19 degrees here, I want to find this. So I'm going to do 90 minus 19 to get my final answer of 71 degrees. Okay, so looking at this one, we're given those 2 angles. What do we know about them? They add up to 90 degrees. So that's what I'm going to do. I'm going to go 3x plus 2 plus 12x minus 17 equals 90. Let me combine my like terms. So that's 15x. It's minus 15 equals 90. Add 15, add 15. I get 15x equals 105. Divide that by 15, divide that by 15. I get x equals 7. Not my answer, but at least we needed it. They want JHI. JHI, so they want this part. So if you're thinking alternate interior, it's going to be equal to this part here. So you want to just plug it into that, okay? So it's 3 times 7 plus 2. And that's equal to the measure of angle JHI, which means 7 times 3 gives me 21, plus 2 is 23, and it's 23 degrees. That's it. Moving on to the next one. You want x, z, y. I'm going to solve for x first. So what do I know? Those 2 are not alternate interior. Those 2 are. So I can actually, if this is equal to that, I'm just going to put it back over here. So this is 5x minus 8 degrees. What do you know about these 2? That's exactly what we just did. They add up to 90 degrees. So I'm going to have 5x minus 8 plus x plus 20 equals 90. Let me combine my like terms. 5x, 1x is 6x, minus 8 plus 20 is plus 12, equals 90. Subtract 12, subtract 12. Sorry, Malibu probably sees a leaf. 6x equals 78, divide by 6. Promise she will potentially stop soon, barking or not, who knows. So I get x equals 13. Okay? So, next thing I have is I want to just figure out what I want. So that's xzw. xzw. So I want this part here. So let's plug that in. It's 5 times 13 minus 8. 65 minus 8. 57 degrees. That's my answer there. Last one that I'm going to do is number 13. It says just solve for x, which is nice. What do I have? I don't have a relationship between those two as far as I know, so I'm going to find this little inside angle because those two are supplementary. So I'm doing 180 minus 134. When I do 180 minus 134, I get 46. So this is 46. The other thing I'm going to think about is I'm just going to use this triangle real quick. This beautiful isosceles triangle, I have an irene there. I could say this plus 5x plus 7 plus this equals 180. However, I'm just going to find out how much this angle individually adds up to and set the two equal. Doesn't matter which one you're doing. Do whatever one makes you happy. So I'm going to do, if this is 46 and those two are congruent, I'm going to do 180 minus 46, which gives me 134. And I'm going to divide it by 2, which gives me 67. So each of these is 67. 67. So I know this is also equal to 67, so just set those two equal to each other. So I'm going to have 5x plus 7 equals 67, minus 7, minus 7. I get 5x equals 60. Divide by 5, and you get x equals 12. That's it for this section.